I'm currently in the laser lab at Luleå University of Technology. And in this laser lab, we work mostly with lasers and laser processings. And currently I stand in front of a big CNC station that I use for my experiments. So here you see a typical CNC controlled laser processing station. Up here we have some laser optics that focus a laser beam onto a substrate. And I work with this wire here. It's a very thin wire. I hope you can see that. And I try to coat surfaces with these wires. My problem, I can show you something for it. So we are working with nuclear energy, and in particular, I work with the nuclear fuel tubes. Here you see a short section of one of those fuel tubes, and I try to put a corrosion-resistant coating onto those fuel tubes. So I have a lot of these samples. I try different parameters, different laser settings, and then we see what coating we produce on top of this tube. And these tubes should be used to contain the fuel in the nuclear reactor. So we're trying to build a small modular reactor, a research reactor actually, that should demonstrate the technology that we try to use here. So it's a liquid lead cooled reactor, and it hasn't been running in Europe so far. So we try to build a research reactor where we can test different materials and different settings on the reactor. And also we want to test these coatings that we produce here and see how stable they are. I would say it's going very well in my particular part of the project. So we were able to produce the first useful coatings, and these coatings will be sent to MIT soon for some irradiation testing. And it looks like they are very stable against corrosion, and they seem to work as we wanted. Now the challenge is to make the process faster, make it more productive, and make it more energy efficient to produce those coatings so we can upscale the process.